Hello and welcome to the Math Admin YouTube channel. In this video, I will solve some problems to help you in your second quiz. Okay, let's start. Here we have geometric series. What's the formula for geometric series? First, divided by 1 minus r. If absolute value of r less than 1. So here we have 3 over 7. It's less than 1, so we can apply this formula. What is first? First is just substitute the first one here. Here it is n equals 3. Substitute n equals 3, you get like this: 3 over 7 cubed, okay, over 1 minus 3 over 7. Let's simplify the answer here. So this here equals 3 cubed over 7 cubed, okay, over 1 minus 3 over 7. Now multiply the numerator and denominator by 7 cubed, because you need to simplify the answer. So here we have 3 cubed over 7 cubed minus 3 times 7 squared. So we have 27 over 343 minus 147, and this here equals 27 over what? Over 196. Is that correct? Yes, it's correct. Let's go to next problem. We have this now. We have summation from n equals 4 to infinity 4n to 9 over 2n cubed plus 4n to 5. What do you think? Is this one convergent or divergent? First, let's use the divergence test. Limit 4n to 9 over 2n cubed plus 4n to 5 as n goes to infinity. The limit will be infinity is not 0. So the series is divergent, okay? The limit is infinity because here the power is higher than the denominator, okay? To show it, to prove that this limit is infinity, let's do the following: 4n to 9 over 2n cubed plus 4n to 5, minimize, maximize. You will have n to 9, for example, and here maximize, you have, for example, 2n, here n to 4, 4n to 5. Must be a problem with me. My handwriting was not clear, but it's clear. 4n to 5. So 2n to 4, not 4, 5, for example. 2n to 5 plus 4n to 5. This equals n to 9 over 6n to 5 equals 1 over 6n to 4. This goes to infinity. So this one must go to infinity, okay? So here, this limit is infinity, not 0. So divergent, okay? Now the next problem. Now, is this one convergent or divergent? It's convergent. Let's see why. N cubed plus 2n plus 5 over 5 to n squared plus 1, okay? Now this is less than or equal to maximize, minimize 19 n cubed, for example. Minimize 19 n to 7, for example. Remember that exponential is stronger than any polynomial. So I can put here 19 n to 7, for example. This here equals 1 over n to 4. This one is convergent. So the original one is convergent. okay? And here you should write for n sufficiently large, okay? I have here exponent n squared plus 1, so I know, I mean, it will be sufficient from the start. But let's check. I need 19 n to 7. Remember that 5 to n squared plus 1, I minimized it to 19 n to 7. So let's see that why this is true. Less than or equal to 5 n squared plus 1. Substitute n equals 1. You get, if you substitute n equals 1, you get 5 squared. You get n equal to 19 times 1 to 7, just 19. It's correct. Now let's say n equals 2. You have 5 to 5. 2 squared plus 1 is 5, okay? So 5 to 5. Is it greater than or equal to 19 times n to 7? 2 to 7, because I substituted 2. Is it correct? Let's see. What is 2 to 7? 2 to 7 is 128 times 19. You will get, I think, this. Let's check. So we have 19 times 128. Yes, I am good in calculations. 5 to 5 will be, I think, 3,125. Yes, 5 to 5. Okay, so the equality is correct. The next one, you don't need to check it, because see, 5 to 3 squared plus 1 will be 5 to 10, greater than or equal to 19 times 3 to 7. Okay, this here is clearly true. Why? Let's see why. 19 times 3 to 7 is less than or equal to 5 squared times 5 to 7 equals 5 to 9. Less than or equal to 5 to 9. So it's easily correct, okay? This inequality is correct for all n, because the growth of exponential is stronger than polynomial. For all n is greater than or equal to 1. Now the next one. This one is easy, right? N to 5 plus sine n plus 3 over n to 8 plus 19. It's less than or equal to maximize, minimize. For example, 256 n to 5. Here the number is number big enough. I mean, you can put, for example, the maximum of sine is 1. I mean, you can write like this: n to 5 plus n to 5 plus 3 n to 5. And say that n to 5 is less than to n5, sine n is less than to n5, because sine n is less than to 1. 3 is less than to 3 into, like this. And then you write 5 into 5, for example. But it's good to write like this, for example. Now let's continue. Now we want to minimize, right? Yes, it's right. Minimize, minimize. Just keep n to 8. Okay, so n to 8, because 19 is positive. If you remove 19, you are minimizing. Okay, this equals 256 times 1 over n cubed. This one is convergent, because 3b equals 3 is greater than 1. Now we have this one. What do you think about this one? Is it easy or difficult? How can we solve it? First, let's see this sign. Note here that sine 2n plus 1 pi over 2 can be written in another way. This here equals minus 1 to n. Okay, let's see why. if you substitute n equals 1, you get sine 3 pi over 2. This here is 270 degrees. Sine 270 degrees equals minus 1. Okay, equals minus 1 to 1. Now the next one, sine, substitute n equals 2, you get 5 pi over 2, sine 450 degrees. Okay, equals sine 90 degrees equals 1, equals minus 1 squared. So in general, you have this equation, minus 1 to n, okay? So this series here equals n equals 1 to infinity minus 1 to n over cube root of n. Is this series here convergent? Yes, it is. Why? Because Bn equals 1 over cube root of n is greater than 0. Strictly positive, okay? Second condition, we need limit Bn as n goes to infinity is 0. And it's also satisfied. Now, is it decreasing? Yes, Bn is decreasing, clearly decreasing. If you want, you can use the derivative to show that it's decreasing, but here in this example, it's clearly decreasing, okay? Because here you have 1 over cube root of n. Cube root of n is increasing. So you have, every time you have denominator bigger than the previous one, so you are decreasing, okay? Now, the next one. Wow. This here, this one is important. Is this one here convergent or divergent? It will be divergent. Let's see why. N to 7 minus 17 over n to 8 plus 5. Okay. This here is greater than or equal to n to 7 minus n to 7 over 5. Let's choose 3. You can choose 5 if you want, but I want to try 3. Here minimize, here maximize. Here, but for example, 2n, no. I need to put something clear here, max for this one. So let's put 9 into 8. The best thing to put it is 6 into 8, okay? Because here you have here 5 plus 1, 6, okay? But I will want to put 9. Now, you have here like this, 2 over 3 into 7 over 9 into 8. And this equals 2 over 27, okay, times 1 over n. So this one divergent, because harmonic series. Divergent, b equals 1. So this one is also divergent. Now let's see why this equality is correct. We need to prove that n to 7 minus n to 7 over 3 is now equal to n to 7 minus 17. Why this is here? Why here this is correct? Get rid of this here, n to 7.